All right, and away we go. I know the last assignment we were dealing with the new tree diagrams and everything. We'll absolutely get back to that with counting principle, but I believe this assignment is getting back to the basics of probabilities. So again, one more real quick time. What is the whole art of probabilities? And with the problems to kind of specify what we are looking for in this. They're broken down into, in essence, two different categories. One, where we're given table problems. In table problems, there's the four basics. So what is the probability of A, or something like that? Well, it would be the number of A's out of the total. What is the probability when we have the word and, like A and B? What you do is you look for the intersection out of the total. If the two things don't intersect, then it's 0 out of the total. Okay, they don't intersect anywhere, then it'd be 0. The word or, okay, you add up the two different things and you subtract off any intersection. Again, sometimes there isn't an intersection, so that intersection would be 0. And again, that's out of the total. And the total is usually found in the lower right corner. And then the tricky one is the word given. Like A given B. This is the word given. The vertical line is the word given. Sometimes it'll be written as the word given. Sometimes it'll be a vertical line. What you do in this situation is the second piece now becomes the total number. So usually it's the bottom right corner, but in this case, the number of B's would be the total, and the intersection is the numerator. So the number of A's in that B. Okay, those are table problems. And then on the word problems, those are usually and then problems. Like this happens and then that happens. So again, the basics of what and how you handle an and in general is multiplication. Okay, it's this and then that. You multiply the two probabilities together. So if they are independent events, that means they don't have anything to do with each other, like rolling a die and flipping a coin. It's just a straight up multiplication. Okay, however, if in a lot of the other problems, it's the same concept where you're multiplying A with, multiplying with probability of B, but that's assuming that A already took place. Right? Or vice versa. Just like you could multiply probability of B times the probability of A. Doesn't really matter as long as the A is with the B. All right, so those are your various probabilities. Again, or is the same for both tables and normal problems. Just note that that is the word and when you're doing the and problems, the or problems. Okay, so let's start this thing. Here we go. Student councils made a 4-minute. I think this is the exact same worksheet that we did maybe last time. I'm not exactly sure. I think this is the exact same questions as we've done before, but again, more practice, who really cares? One of the women is a president. What is the probability that a woman is selected? Well, there's 4 women out of 10 total. A man is selected, that's 6 out of 10. What's the probability that the president is selected? That's 1 out of 10. On to the jar problem. There are 6 red, 8 green, and 3 blue. The first question is with replacement. So I put it back. So I select a red. which turns that into a 5 and a 16. But because I put it back, that reverts it back to a 6 and a 17. So a red and then a green. Okay, so the next one is without replacement. So I select a red. And I'm not putting those back, so those numbers are going to stay different. And then a green. The Dean of Hillsdale College found that 12% of female students are majoring in computer science. So it's already known that they are, given that they're female, okay? And so that would be computer science, given that they're already female. So given that they're female, 12% are in computer science. 64% are female. So being a female is 64%. What's the probability of being a female and in computer science? So probability of being a female and computer science. And so with the variables that we have, that would be F times C. And so that'd be 0.64 times 0.12. Okay, table problems. So satisfied, there's 180 of them. The word given, so the second piece is going to become the total, so the 12th graders are the total. And the intersection with satisfied. Next is just straight up 11th grade. And then the word and, which is the intersection of neutral and ninth. So the intersection of neutral and ninth. Notice all of these things are out of 417 except for the problem that uses the word given. In essence, these are still a table problem dealing with the word or. Again, or is you add them up and subtract the intersection out of the total. So here we have a heart, or a spade, minus any intersections out of the total. I'll come back to that one. Next, we have a jack, or a diamond. Subtract any intersections out of the total. All right, so the first one is 26 out of 52, that's 1/2. And then the second one is what, 16 out of 52? And the last one is the law of large numbers, so coin. Yeah, so when you deal with this last question, again, don't read into it too much. It's just usually that if they bring up the mention of a coin, the probability is usually going to be 1/2. If they bring up a dice, okay, the answer is usually going to be 1/6. So just those are your 2 industry standards of general probabilities.